Hello and welcome to this UPE Python tutorial. In this video, we will be going over generators and specifically why you would want to use them, plus the advantages that they serve. So to start, what I've done is written a simple f of x function. And what it does is it takes in a list of integers, and for each value in that list, what it's going to do is calculate 2 times that value minus 1. And then it'll take that value and append it to our result list. At the very end, once we've done this for each value in our input list, we will return the new list of calculated values. So if we go ahead and run this, you'll see that we get a list of all odd numbers. So in order to go ahead and make this written function into a generator, we're just going to make some minor edits to the code that we've already written. So we'll take out that line, and we'll also take out this return statement. Instead of appending to a list, what you're going to do is replace this with a yield statement, and it'll yield the 2 times that list value minus 1. So now if we go ahead and run that, so I'll save and run that, you'll see instead our print statement returns a generator object. And this is because generators do not store the entire result in memory. What it instead does is it yields one result at a time, and this helps to reduce the amount of memory needed. So the generator waits for us to ask it for the next result, and it doesn't compute anything until we ask for it. Now, in order to go ahead and print a value, what we're going to do is make some slight modifications to this code down here. So we'll instead call this result. We'll set it equal to that generator object. And then right below that, in order to print a value, what we're going to do is call a print statement, and we'll call next on result. So now if we save and run that, you'll see that it only prints one value, and it's the first value that would have printed in our list implementation version of that function. Now if we go ahead and add this print statement a couple more times, if we save and run that, you'll see that it goes through each value one at a time. So every time the next function gets called, it goes to the next value in the generator, and then it prints it out onto the console. So you'll see that for the 5 times it printed out our 5 values. But if we add another print statement, what you're going to see is we're going to get an exception, because now we're going to reach the end of our generator object. And you'll see the exception that we get is the stop iteration exception. So now instead of yielding a value from our generator one at a time, we can still use a for loop to iterate through our values in that generator. So we'll just delete this, and we're going to write a for loop. So for I in result, we're just going to print that value. If we save and run that, you'll see that it goes through our generator object and it prints each value. And you can also see that it takes care of the stop iteration exception because it knows where it should stop. So another implementation for this exact same function is through list comprehension. So if I go ahead and delete some of this code up here, and instead make result list comprehension. So what I'll do is I'll say 2 times I minus 1 for I in 1, 2, 3, 4, and 5. If I go ahead and run that now, you see that we get the exact same results as before. So now, if you're familiar with list comprehensions like I've done here, you can also make a generator object in the exact same manner. And it's really easy if you know list comprehensions, because all you have to do is replace those outer brackets with parentheses. And you'll see if we just do a print result here before we go and print every value, it'll return a generator object. So you see that we get a generator object, and then it goes through and prints every value in that generator. In the case that you ever wanted to print out all the results of the generator object on one line, like we do with lists, what you would do is cast the list function onto your generator. So if we do that, and we delete the code below that, you'll see that it prints out in the exact same manner as a list. Now, converting the generator to a list, however, diminishes the advantages that come with generator objects. The advantage of generators is that it doesn't hold all the values in memory which get calculated during the function calls, and for smaller inputs like the ones we've been demonstrating in this video, it won't really make much of a difference, but the performance is very noticeable when you deal with larger objects. And I'll go into an example now where you see the performance benefits. Now, what I've done here is written out both the list and generator implementations for the code shown before, and then added some metric tracking so that we can see the performance differences in execution time and memory used. For input, I generated a list of 100 million length so that you can really see the performance differences. Our first run will be with the list implementation. So I'll go ahead and run this and give it some time to execute. So these are the results for our list implementation, and I'll quickly switch it over to our generator implementation and then execute that. As you can see by comparing the results, both the execution time and memory usage have been reduced drastically. This is because generators only work on demand, which is often referred to as lazy evaluation. This means that we save on CPU, memory, and other computational resources. So to recap everything demonstrated in this video, I showed you how generators in Python help to reduce memory usage and execute our code faster. The advantages for generators lie within the fact that they do not need to store results in memory, and that they are only used when we ask for a result. Another pro to generators is that they abstract away a lot of the boilerplate code needed when writing iterators, which helps ease the readability and size of our code. If you have any other questions, please direct them to upe.uconn.edu. Thanks for watching.